I guess so. So which do you think is the, which do you think iron would rather be, 3 plus or 2 plus? 3 plus. And the reason why, with 3 plus, you get rid of the fourth energy level and you're half filled. You've got two good things going for you. Fourth energy level empty and you're half filled. Whereas the top one, the 2 plus, you just get rid of the fourth energy level.
But doesn't that follow rule 1?
Yeah, it follows rule 1, but here you get rule 1 and rule 3. You get the benefit of both of them. So, it is the twofer. So let me hand out your homework. Your homework tonight is to read 10.1. Yeah. Actually, can you just hold on just a second?
Just spontaneously combusted.
Can you hold on just till the directions are done?
Yeah.
Oh, yeah.
I just got one back.
Yeah.
Yeah.
Yeah, we should.
Oh, Julie did 10 for on this side.
So for homework, I want you to read 10.1 in the book, and then to do 10.1 worksheet. That's just the front side. The back side is 10.2. So you're just doing the front side, and then let's take a look at number 5 and number 6. For number 5, could you read number 5, Kim?
If iron has an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6, how does it form iron with oxidation numbers of 2 plus and 3 plus?
Okay, the word oxidation number means charge. Okay. Well, there is a slight difference between oxidation number and charge. But for our purposes in this class, when you see the word oxidation number, you can just replace it with charge. When you take AP chemistry, you will learn the difference between a charge and an oxidation number. But for the most part, they're very similar. And so number 6 does the same thing. It asks you to predict the most likely oxidation number or the most likely charge for those following things. So let's just do one example together of number 6. Suppose, no, I'm going to pick my own. Suppose we were going to do this. No, let's not do that. Let's do this one. 1s2, 2s2, 2p1. Now, don't forget you can add electrons too. You don't have to just take away. So, the most likely scenario is to get rid of all of the second energy level and form a 3 plus charge. Now, sometimes there are other options that don't happen too often. Like you could just get rid of the 2p1, and then you'd have a 1 plus. But which is better, to get rid of the whole energy level or just a sublevel? The whole level. So it might be a 3 plus 99.9% of the time, and 0.1% of the time it'll form a 1 plus. So that's why, like, you know, in theory, you can make any element any charge you want. But, you know, when we memorize the charges, we go with the ones that, you know, they're what charge they are most of the time. The alkalis, they're always, almost always +1. Could I make it a +2 or a -1? Sure. But, you know, 99.9% of the time they're +1. Things like iron, where it's +2 or +3, they'll be those charges, you know, more often. They'll switch between them fairly often. So they don't say, oh, it's always +3. So, any other questions on the homework? All right.